So this is the only way I think we can get this out of here. We got 2 screws, or bolts rather, heading in, and they should push up here, I hope. Okay, so this is the underside, and there is no way I can get that up. So maybe, so there's no through holes here, must be through holes there. Maybe I can crank this up. Otherwise it would be like knocking the spindle out. Okay, so these threads don't actually extend down, which means it's probably a job for a hooky. Make one and then pull it up on the gantry. I think that might be an option. Or maybe a slide hammer. Yeah. Can I do that? Okay, well here's my return to cleverness. I can actually use these bolts here with my phone and my other hand to actually sand all the way to the bottom by wrapping it around. So sweet. There, I get to phone a friend back. Okay, so I reached out to Evaporust about what can actually go in here without being harmed, and as long as there's nothing that can be oxidized or with respect to insulation, this should be okay. Odds are it's screwed anyway, so I'm just going to plunk it in and see what I can do with it. So it's going to go right in the tub. Okay, so still nothing has happened here. It's been several hours of soaking with it. So I think while I could reconsider my plan of action, I'm going to start taking off the lever assembly and the gear change assembly on the inside. So that should be pretty easy. There's a set screw here, a pin of some sort, another set screw, and then just a screw for the one on the side here. So we'll mark its position, where it comes from, and all that sort of stuff, and then just take it out. That might give us some more opportunity. I actually thought about putting a toe jack in here and lifting up that way, but then my surface contact area is not that much, and if the gear itself is I don't know, if the arbor rather is being bound up on the power feed somehow, then I don't want to snap anything. That's my big worry. Behind this set screw we have our alignment adjustment, I believe. It just looks like an old nut wedged in there. I don't think there's actually anything else in there. There was probably supposed to be a pin that would keep it in that area. So that means to me that, whoa, how to focus. That means to me that this has been looked at before. Okay, little taps here and there. I was able to free everything up, so now we both the right and the left side good to go. So should be able to make some relatively quick progress here. Figure out how that switching mechanism at the back works. Looks like there's a pin that shuffles from one side to the other. Okay, onward. So each one of these grub screws is about 1/8, so these set screws are 1/8. And it looks like it's pinning here. I'm not sure what I'm going to do about that. There's no pin going through the other side, and it would be awfully difficult to remove a pin. I mean, it could be pinned. Very well might be pinned before this comes out, and there's no movement on this at all, so I have no real clue how to do that other than maybe get a screwdriver or something like a chisel and try to knock them out. Don't know. Anyway, yeah. Okay, more to come. All right, here's the pin mechanism that switches. Now, there is quite a bit of wear on this side, but that switches and sort of locks it in the center for neutral. So this grub screw will come out of here, and we'll save this. Take a look at what we need to do once we get back to this part. So I'm going to get that out now. And that should just come out, because that screw would likely just be holding it in a sleeve, and then it'll pop out. So take your 1/8, pop it out and save it. Okay, there's the ball bearing out of one side. There's got to be more than one in here. There might even be 3. I don't know. Either way, I'm going to have to get that sleeve out, and maybe we'll need more. I don't know. More ball bearings, that is. Okay, so I'm going to store this with the right side. Okay, here's the other one at the other side. So there were at least 2. And kaplunk. That's probably how many there were. Yeah. All right, that's good enough for now. Still have to get that piece out of there. But yeah, all right. Back to the levers. Okay, so on the ball bearing train here, there's actually a ball bearing on this. So unlike the other one that had a spring pushing on it, which made a lot more sense than the top of the top of a screw, we've got a ball bearing here that follows a track, and that makes a lot more sense. So this is on the right side. All right, back at it here. I am becoming more and more convinced that something is seized down in this operating area. I don't know the mechanics of the machine yet, but maybe I should focus my efforts on there rather than up here. I'm really not interested in breaking the casting open more, so what I think I might do is just take off all the peripheral side equipment and stuff like that, and just start to get into, well, that part where the drum is. Okay, back on the side here, we have our gasket for the mating surfaces between there, which gets fed through here. So I think I'll start there. I think I can tell that, I mean, obviously there's fastener holes through here, so that must mean that there's there we go. You can kind of see it in the corner there. There's going to be one here, probably 4 screws. Those look like they're almost out already, or whatever that is. Take a picture, maybe you guys can see it, or maybe I can see it when I check this film, whatever that is. But I'm going to take these flatheads out. Yeah. All right, so this is it on its side, and here's sort of the other side of the, I'm just going to call it the upper attachment to the power feed. The gasket is separated, so I should be able to take that plate off and continue moving forward. It's quite difficult to do this with 2 very greasy hands, and I don't have a camera holdy thingy, but whatever, this is how it's getting done. Okay, so here's the other side, and here's our gasket. I'll have to make a new one of these, and you can see through the bottom now, so this sort of meshed up there, and so what that broken piece was certainly part of the gasket for this. Right, with the wheel chocks underneath there, I can get a better access to this panel, which is the next step. Now that we have that freed, so to speak. So looks like more flatheads. You can kind of see some buried under the grease there, and yeah. Okay, here we go. Okay, with those 3 nuts taken out, man, language, come on, so tired. Those 3 flathead fasteners taken out, now we can get into the gear train of the power feed. So that's also not movable by hand, which I don't really expect it to be. So we're probably bound there, and kind of start to see what's going on here. So this is turning, but the cams aren't connecting.
there's some sort of engagement that has to happen. There we go. That goes in. That's got to get held in. Okay. So that's that lever there. And then this should turn. Foot. Okay. It's turning. I don't really know if it's moving though. All right, I need to answer this. Okay, well, I turned that over a couple times and it didn't seem to be a super big problem, but I guess this was in the ocean too, because there's seaweed. I have no idea what else that could be. Gasket material or something? I really don't know. Anyway, so lots to clean up in here. This is not connected to the spindle right now. So that means the spindle is still jammed. Damn it. All right, I'm not too sure how this attaches. All of these are broken off, so I'd have to drill these out. Now, this is either from manufacturing this little hole here, like on the lathe, for example, to thread it, or it sort of doubles as a pull for a bearing puller. And if you look through here, you can sort of see that shape. That's iron, but there's like a wedge in it. And yeah, so got to figure out how to get this out. But I guess technically this still isn't helping the spindle problem. Or at least not from this side. So while I ponder what to do, I'll hit this little area with penetrating oil and go from there, I guess. Yeah, that's what we're gonna do. Thinking cap time. So the more I clean this and think about it, the more I wonder is whether or not something like inside here, where the rest of that chain goes, is binding, you know, holding it up. So I'm going to loosen the chain from here. Yeah, and so once it becomes unchained, I guess we're just going to Van Halen it. Okay, well, I still have it on an angle. It makes it somewhat easy to do this. So I'm going to take off the electronics, see if there's any sort of sneaky hidden port back here. And then figure out what I'm gonna do. Oh, with that off, we can clearly see the pecking order. This is not the first time there's been something on it. But yeah, still engaged with this, gonna keep going. All right, cover off. That's sweet, like you have this plastic barrier there to make sure the directions are good, and then here's our inside. Aside from the odd spider web, looks pretty nice. Try to keep that. I really like these sort of barrel switches. I think it's awesome. So, okay, gonna keep going here and get those other fasteners out and just remove the electronics from the whole thing. Okay, with this off, fortunately there's nothing visible on that side. This little fastener thing right there, what I might do is just take that out and pump the whole chamber full of penetrating oil, see if that helps get anywhere. Probably not a bad idea. So this is that crack in the casting I was talking about before. It is a weird break. It almost looks cut. Yeah, anyways, that'll be an interesting thing. That's probably going to be the brazing component here. I thought it was just cut originally, but if I hold this here and take this out, it looks pretty much like it's been cracked, because it's not clean, right? So yeah. Okay, so this is my last ditch hope, I guess you could say. So this chain has to be connected to here, and it's obviously not. There's nothing working there. Something's hitting, so it's not binding. So it's broken here, and I really hope this just fell, cracked, nothing else is damaged, and this, the actual spindle isn't moving up and down because it's well seized thanks to the rust. It has nothing to do with like it almost needs to be pulled down, if that makes any sense. That's what I'm hoping is going on. So there's a section in here where I can take off. If I pull it there, this is the connecting area here. You can probably see that wire. So I'm just gonna separate it. I don't want any more tension on there than there needs to be. And I should be able to pull it out. So yeah. Okay, so that worked out surprisingly fine. I thought this was going to be pinned, but it's threaded actually. And of course, we can't take this out because this mechanism is here. Cool. Maybe I can get that out instead. How much grease on my phone? So I was able to actually get this out using a bit of creativity. By pushing up on that bearing, you can actually rotate the bottom assembly, reposition it on the fastener, and then use the weight of it once you set it down again to move the fastener out. So I've been cleaning up here. Looks like we got another set screw to get rid of at this point. I'm not sure what these are, than the spacers. I thought it might have been some sort of spring. No idea what's going on here. Yeah, so I guess I'm gonna keep going at this stage and try to figure out that's the best way of getting this out. I'm pretty sure you got to do it from the other side, but yeah. So I decided to go ahead with the pin because they look like pin stuff, and I figured out what these are. This is actually a bearing. So underneath those two locks, there is a bearing here. Neat. And yeah, cool. Okay, so I've sprayed I've sprayed penetrating oil between the bearing and the actual spindle. Now I'm going to try to get rid of some of the surface rust because this is pretty tight fit down there. So back and forth, back and forth. Okay, try as I might, I keep rounding the edge of something here. This has been heated several times, and I still can't get the pry bar in. So I'm going to try to film it with the bar and see what exactly is going wrong. Okay, that's exactly where it should be. And I'm getting no movement. Well, I'm at a loss again. So I guess I'm just dumping this full of penetrating oil and hoping for the best. Okay, so this taper pin is holding this set of the worm next to one of the main drives there, driving gears. So I'm trying to just remove little bits and pieces as I can so I can figure out what exactly is holding on this, if anything. I certainly don't want to try to extract it. I have a feeling that underneath where everything broke off, there's actually set screws, but that would suck. It's not out of the question though. This is British made and they do love taper pins. So I guess we'll see. So I'm just gonna pull this out and then remove this section here, store that with the pin, and we'll get this assembly off. Okay, the way that I ended up doing with this was locking this together and then just starting to turn it now that that pin is out, and it came out nicely. So be able to restore that. Looks great. And into the bin. Okay, onward. All right, so the other two pieces came up pretty easily as well. This piece is part of the bottom, and then this piece is obviously on top. And you sort of work it way down using the thread that's there, and then they both come out no problem. So that's good. I'll be able to get the pin, which I had to push out inside, and should be able to take out the rest of this stuff. So before I get into drilling them, I thought I'd try to heat this up and take this out with a nice tight wound coil. It's just a matter of seconds before it gets going. Give it a couple smacks, then I'll try it again with the soft jaws. That stinks. Did that just move? Okay, so the heat worked, and I thought this would have been threaded the opposite direction, but it's not. So it's a left out. Anyways, yeah, I'll take this out and see if there's anything underneath it. Well, that kind of sucks. The hex end is on the inside. What? And it's definitely long enough that it's holding onto the shaft. God damn, why? What am I missing? Why would anybody do that?
Alright, so tapping this side on the chip edge here, which should have given it enough purchase, didn't do anything. So I'm going to take advantage of the open hole here. You can see down into it. It's sort of difficult, actually. We probably won't be able to see it unless I put the flash on, but there's no... yeah, you can't see it right now. There's no mark as if it was resting against something here. So these may not actually hold on to it, which would be awesome. Especially since they're seized, because it's an awkward way to drill that out right now. Okay, I'm going to continue. I still don't know how this comes out, and I don't want to rookie myself and make more damage. All right, I remade the coil with the new fiberglass insulation. We got it so we're really nice and warm in there. Still nothing. So this is a 1/2 inch 13, which is nice. And we are just not engaging on anything. So, Okay, so I'm going to vent my frustration somewhere else, I guess. We have a taper pin here. Or not taper pin, but one of those... oh no, this is the Allen. On the other side of this, there's actually one of those... I forget the name of the pins. The roll pins. And so here we get to use the actually flathead screwdrivers, not like the sort of triangular diamond-shaped ones that are normally referred to as flathead. And back that out, and then I should be able to access the pin, punch that out, and then we might get some more freedom here to further increase our disassembly ability. All right, and so the trick worked using the magnetizing the bit of an Allen key and slowly hauling it out. You can see it there. I don't think there's enough. Oh, we got it. There we go. Perfect. Okay, put that in the bag. Okay, so to get this out, I've decided to go with the left-hand drill and the die grinder to make an actual spot to even start the drill with the center punch. So I'm going to get my left-hand bits here. I am going to heat this up because that seemed to be a significant improvement. I can't get the induction coil in around that, obviously, so it'll be a torch job. So we'll hit it with the center punch, brush everything off, heat it, and then start drilling. There, sorry. So I just used the die grinder tip here to create something a little bit more workable. All right, here's an example of that process. Okay, so I've got about a 1/4 inch hole or so in there now. I'm going to heat it up, and I'm going to put the biggest, or nearly the biggest one I can in there now. And hopefully there will be enough torque to just spin it out. That's the plan anyway. We'll see what happens. So what I did is chose the appropriate size extractor. I have tried a whole bunch, but never these Irwin ones. They look a lot better. We'll see if they work. She's in there, so I've tapped it in. Yeah, all right. 2 hands probably going to be needed for this, so that I can clap after it doesn't work. Okay, going all out on the cheat. This is like no clip back in the TFC days. Someone's gonna snap. Someone's gonna fucking snap. All right, I am dripping with sweat now, mainly because I'm like one knee on this pad, safety Crocs, you know the drill. The other attempt didn't work. It just kept turning it, and so what I decided to do, you can see all the chips here, is just continue on ahead boring it out. So I'm going to try it again with the extractor. I hate extracting bolts. Gah. Triangles wrapped around wedges. Wedges wrapped around cylinders are so annoying to get out. That didn't work either. Started turning and then just cut itself a nice little smooth bore. I don't understand why every one of these things sucks. I mean, it can't be me. I mean, just because I'm the only variable out of all of them doesn't mean that it's my fault. Okay, well, I've made it through most of that 1/2 inch or whatever it is. It's like a lock nut. No, what is that? Getting into error making mode here. What's it called? Anyways, point being, this one also had the Allen key face down, which means there's got to be a better way to do this, right? Because that means, I mean, one could have been a mistake. Nobody would purposely put all those Allen keys with the drive facing in unless they weren't supposed to be removed from a different direction. Anyway, so this one fits, but there's still too much material left, so I can't turn it. I've tried tapping it with a left-hand tap. I've tried running a 1/2 inch 13 down it. Nothing yet. Jeez. Come on, focus. Stay in focus. Okay. Here's one of the scrap Allen keys, 6mm. It went all the way through, grabbed it, and with a cheater bar and some extra push, we got it moving. God. Now I get to see how much damage is in there. I tried to get it through the center. There's got to be a better way to do this. Has to be. This is ridiculous. If I can only mess up one of these, that would be okay. It's coming out. God. Hey. All right, so I checked metric, I checked imperial. Last thing I had to check, Whitworth. So yes, 12 gauge Whitworth. That makes sense why everything else wasn't quite standard. The only set of stuff I don't have. It makes sense though, right? British. So I will retap the holes that don't work. Or maybe I'll just drill them and put inserts in or something. On the repair side of things, I wonder if someone was getting fired from the factory or something and said, you know what, I'm going to totally screw the next person over and put these all in backwards. I mean, it's got to be me. I gotta be doing something wrong here. So I just happened to look at this, and there's a key. God. There's a key. All right, so I do have to extract this. I'll have to find a way to use the puller. But it was just because of this green light. The shadow was just a little bit different, right? And you can sort of see how it's always hidden by the shadow in the way I have it. So there's a keyway. Yeah. Thank you, 532 nanometer.